Okay, LS5. So first of all, let's write down the algebra. When we say level sets of this function f, what we're talking about, level sets of f are the following. It's, you write down f, so e to the negative, I'm going to rewrite this as e to the negative, and then x squared plus y squared, and then plus z. And the way you form level sets of that function is you set that equal to different constants. Right. And now let me write this a little bit differently. Let me write this as z equals c minus e to the negative x squared plus y squared. So that's the equation of each level set that we're talking about, right? So, okay, so we basically at this point we want to know we want to draw pictures of solution sets to this equation. This becomes a 2.2 problem. And in particular, this is a 2.2 problem for an equation where, hey, check it out, x and y appear only in the special form. That means that this thing is rotationally symmetric around the z-axis. I can pick whatever half plane I want hinged off of the z-axis. So I'm going to take this one here that we have taken in the past. And this is where y is equal to 0 and x is greater than or equal to 0. And with that, so inside of there, x squared plus y squared is just x squared. Right, so the equation becomes z equals c minus e to the negative x squared. So for some value c, c minus that, okay, we'll see. Now e to the negative x squared is kind of a bump, and so c minus that is going to be something kind of like that. You might have to, in order to see what this thing looks like, you might want to draw a series of things. Like, so here's what e to the negative x squared looks like. Oh, I'm sorry, yeah, thank you. So e to the negative x squared looks like that. So negative e to the negative x squared looks like this. And then c minus e to the negative x squared would be, this would just get translated up by some amount up to, if that's where c is, then c minus e to the negative x squared is like that.
So c determines the shift up or down?
Yep, that's right. That's right. So for different values of c, yeah, you get different curves. Absolutely.
And it's also rotated around.
Well, yeah, that's the thing. So what we were looking at here, this equation came from looking just at a cross section in this half plane. So that means our actual surface, this actual level set, you're right, is rotated around, and this is going to be a hard thing to draw. I'm going to take a whack at it here. We're drawing something inside of. It's asymptotic to a plane, but it's got this kind of like depression down in it like that. So all the level sets look kind of like this. And then, of course, there's several of them. I mean, for different values of c, you change the value of c, well, then that's going to be up sort of here like that. And again, with the same little kind of depression. By the way, not my first time drawing a little depression in a plane like that. And so that's how I sort of knew that little trick, right? And so now you guys know that little trick. If you want to draw a little depression, in a plane, well, you just kind of draw the little sort of this side, the near side of the lip, and then you draw the little, angles going down into it, and hey, that conjures the image, right? And this fools your eye, and it communicates to the eye that we're talking about a sheet of rubber that's been kind of pushed down. It's got a depression in it or something. So, yeah. So the problem says draw a representative collection of level sets. So here you go, X, Y, Z.
Excuse me.
Yep, sure. And You know, you could draw maybe an additional one or two of these, whatever. Something kind of like that. Okay.